In this video, let's go ahead and practice writing equivalent algebraic expressions together. Specifically, what we're going to be doing is practicing using something called the distributive property, a little bit more in detail here. So let's go ahead and see how we are going to tackle the first four questions. So notice how for these first four problems, each of these expressions has a set of parentheses, and inside we have two different terms. You could have two or more for these types of problems, but we're just going to have two for each of these, and there's going to be one number on the outside. So for the distributive property, we're going to be distributing the outside number to both inside terms. We're going to go ahead and multiply both over here, okay? So let's go ahead and do that. There are essentially 5 of these 1m's. So let's go ahead and see. We have 5 of these 1m's first. So I'm going to go ahead and write this is going to be 5 multiplied by 1m plus this is also going to be this 5 multiplied by one of these 3. So let's go ahead and write 5 of these 3's. So that's going to be 5 multiplied by 3. If you go ahead and simplify this again, now 5 times 1m is just going to be 5m, and then 5 times 3 is going to be 15. So using the distributive property, this would be our rewritten expression here. We see this 5 on the outside. We go ahead and multiply that by both of those terms on the inside. All right, let's check out number 2. For number 2, we have this 3 on the outside. Let's go ahead and distribute this to both terms on the inside here. So first, we're going to take this 3 and multiply it by the 2n. So it's going to be 3 multiplied by 2n plus. We're going to take this 3 and then we'll distribute it also. There's 3 of those 2n's, but there's also 3 of these 1/3. So it's going to be 3 multiplied by 1/3. Okay, so we're going ahead basically and taking the 3 and we're multiplying by both terms on the inside of the parentheses. Now, if you multiply 3 by this 2n here, that's going to equal 6n. And then if we go ahead and multiply this 3 times 1/3, that's just going to be 3/3 or 1 whole. So this would be our most simplified expression here using the distributive property. Next, let's take this 5 on the outside of this parentheses. Let's go ahead and distribute it to both terms inside here. So we go ahead and do 5 times this 4n. We'll take the 5, multiply by 4n, use the dot to show multiplication. We have a minus here, so let's go ahead and subtract. Let's go ahead and take the 5 multiplied by this 2. So we'll go ahead and write 5 multiplied by that 2. So notice the 5 that was distributed to both terms on the inside. Now if you go ahead and do 5 times this 4m, that's going to be 20m. And then for this 5 times 2, that's just going to be 10. So let's go ahead and write 20m minus 10. All right, for number 6, notice what we have on the outside. It's the 6 here. The 6 is going to distribute to both of these terms on the inside here. But first we'll start with the 6 and multiply that by 2/3 n. But then we're also going to be adding the product of what? Well, we still have to distribute and say that we have 6 of these 5/6. So we're going to go ahead and multiply the 6 by the 5/6 here, this constant term. So let's go ahead and see we distributed the 6 to both of these. Now if we go ahead and look at 6 times 2/3, you can see on the side here that's 6 over 1 times 2 over 3. That's really just 12 over 3, which is equal to 4. So we can say that this part is going to be 4n. And then for the 6 times 5/6, we can see that that's going to be 6 over 1 multiplied by 5 over 6. That's going to be 30 over 6, which simplifies down to just being 5. So this is going to be 4n plus 5. That would be our expression here. All right, for questions 5 through 8, let's go ahead and apply the distributive property again, but in a slightly different way. So for each of these, you're not going to see the parentheses. We're actually going to be trying to get an expression with the parentheses. So we're going to be kind of doing what we call the reverse distributive property, or factoring, as some people might say. And we're going to go ahead and see if we can find the GCF of each of these terms here. So we have this 4x plus 10. I'm going to go ahead and just write that down here. And I'm going to go ahead and use the ladder method and see what common factors we can see here. For 4 and 10, I'm thinking a common factor of 2, because they're both even numbers. 2 times what gets you 4x? Well, it's going to be 2 times 2x gets you 4x. And then 2 times what gets you 10? I think that's going to be 5. So 2 and 5 are relatively prime. Their GCF is 1. So I don't think we can do this anymore. So I think what we're going to write is 2 on the outside of our parentheses times the quantity of 2x plus 5. This right here would be rewriting this expression using the distributive property, or reverse distributive property. If you go ahead and distribute forwards again, like we did in questions 1 through 4, we should get back to what we started with 4x plus 10. All right, for number 6, let's see, we have 15x plus 24. Let's go ahead and use that ladder method or cake method over here. Let's stack this here. Let's look for a common factor. 15 and 24 go through divisibility rules or your factor lists. And let's go with 3 here. 3 times 5 is 15, so 3 times 5x is 15x. And 3 times 8 is 24. And I don't think 5 and 8 have anything else in common. 5's prime and doesn't have any common factors with 8 besides 1. So how are we going to write this? We'll put the 3 on the outside here, and we'll go ahead and write times the quantity of 5x plus 8. That would be inside the parentheses. Again, you could go ahead and distribute forwards using distributive property and make sure you do get what you started with over here. For number 7, we have 16x minus 40y. Don't worry about the 2 variables. We're just going to be doing the same process here, and the minus sign, don't think too hard about it. For 16 and 40, I'm going to go with 8, but feel free to choose other numbers along the way. 8 times 2x would be 16x, and 8 times 5y would be negative 40y. 2 and 5 are both prime, and if they're both prime, we can't go any further here. I'll write that a little nicer. So 8 would be our GCF here, and on the inside would be multiplied the quantity of 2x minus 5y. All right, so that would be this expression using the reverse distributive property. For this next one, for 28x plus 42y, I'm going to go ahead and write those down first, those 2 terms. 28x plus 42y. Let's see, what do they have in common? I think we could go with maybe 7 first. I think there's a bigger number, but I'm just going to show 7. I think most people would choose that first. Let's do 4x plus 6y. And then again, you can always do multiple steps here. So you can see these both have a common factor of 2. So 2 goes into 4x 2 times, and 2 goes into 6y 3 times. So we're going to have 2x plus 3y here. Okay, so on the side here, we can see our GCF would be 14, 7 times 2. So we can go ahead and say this would be equal to 14 times the quantity of 2x plus 3y. All right, so this would be our equivalent expression. And if you distributed, that would be 28x, that would be 42y. And it matches these 2 terms here, and the coefficients match as well. All right, let's try numbers 9 and 10. Here we're going to select all, so keep in mind that we are going to have sometimes maybe more than one answer here. We're going to select all the expressions that are equivalent. Remember, equivalent means that they are equal to the given expression or have the same value. And also, let's go ahead and make sure we provide some evidence to make sure that we are justifying what we're saying. All right, so the given expression we have for number 9 is going to be 5x plus 10. That's the original. So let's go ahead and see. If we take a look at this first option here, we have these 2 different terms here. We have 10x minus 5x. So if you combine those like terms, 10x minus 5x is going to be 5x. And then you have this constant term of a 10 here. So that's just going to be plus 10. So the question is this the same thing as what we started with? I think the answer is yes. So I'm going to go ahead and just put a check mark saying that one is correct. If we take a look at the second choice here, 15x, well, you can see here that the coefficient here does not match the coefficient. Also, there's a constant of plus 0 here that's invisible, but we have a constant of plus 10. So this one does not work. All right, you can't combine like terms here. So I'm just going to say that we have the wrong coefficient and constant here. All right, for this next one, let's go ahead and take this expression here and distribute. So this is going to be 5 times 1x. So that's going to be 5 times 1x plus, and we also distribute and say this would be 5 multiplied by 10. So it's going to be 5 multiplied by 10. So 5 times 1x first is going to be 5x. And then this 5 times 10 here is going to be 50. So that's going to be this expression if you kind of rewrite it like this. You can see here that the coefficients and the variable terms do match here. However, you can see here that the constant terms are incorrect. They're not the same value here. So this is not going to be one of the equivalent expressions. So the reason why these aren't equivalent expressions is because we have the wrong constant or wrong constant term. All right, for this next one, let's go ahead and distribute this 5 to this x. That's just like the last one. It's going to be 5 multiplied by 1x plus, we have a plus sign here in this problem, then 5 multiplied by 2. Do 5 times 2 here. And so 5 times 1x for this first part is just going to be 5x. And then for the second product here, 5 times 2, that's going to be 10. So compare the variable term and coefficients, 5x, 5x, wonderful. And the constant of 10 and 10, that is also wonderful. So we know this one over here is going to be an equivalent expression. All right, for this last one here, notice that we have 2 of these x plus 2's, and we have also 3 more of these x plus 2's. So if we have 2 of these x plus 2's plus 3 more of these x plus 2's, what we could say here is that we have a total of 5 of these x plus 2's. Right? So keep in mind that it's really just we have how many of these x plus 2's kind of grouped here. And then if you look at this expression of 5 times this x plus 2 and 5 times this x plus 2, these are the same thing. So if we go ahead and distribute just like we did in the last expression, you're going to notice this equals 5x plus 10, which is the same exact expression. So this one is going to be equivalent as well. All right, so we have 3 different expressions here that were equivalent to the original given one. All right, let's try number 10. For number 10, let's look at our original expression, this 4/3 y minus 9 plus 2/3 y. Let's go ahead and see if we can simplify this, because I see some like terms here, so hopefully that rings a bell as well. So these are like terms. If we go ahead and take the 4/3 coefficient and add it to the 2/3 coefficient for the y terms, you're going to get a total of 6/3, which is equal to 2, right? So we're really going to say this is going to be 2y. And then we have a constant term. Keep in mind that this minus, it means that it's a plus a negative 9 if you add the opposite. So 2y minus 9, this would be our most simplified version of this expression. So let's see if which one of these could maybe be the same thing here. Well, for this first answer choice for 11y, maybe they tried combining these and they also thought maybe this was a positive 9, so 2 plus 9 is 11. But we hopefully know this is not correct here. Why? And it's because we have the wrong coefficient. Our coefficient here is supposed to be 2, but we have 11. And then we have the wrong constant term. There is technically a plus 0 at the end here, and we have a minus 9. So the coefficient and constant are both wrong. Okay. For this next one here, it says 2/3 y plus 9. Again, for the same reason as the last one, we have the wrong coefficient and we have the wrong constant. So there's a couple things that are wrong. I think they might have did 4/3 minus 2/3. I think they might have subtracted them to see to get 2/3 here. And then I think they might have just forgot that they might have forgot the minus sign here and just said it was plus 9 here. So for some other reason, we can say this expression is not equivalent, because again, we have the wrong coefficient and wrong constant. So they kind of combined or maybe got their signs mixed up a little bit. All right. For this next one, if you look at the expression, notice how the coefficients do match perfectly and the constants of -9 also match perfectly. So this one's not a lot of work. This one works really nicely. For this next one, let's take this 1/2 and go ahead and distribute it to both terms here. So we go ahead and do that. We have 1/2 being multiplied by 4y. And we have a minus sign here, and then we have 1/2 multiplied by this 18. So that's going to be half of whatever 18 is. Okay, so let's go ahead and see what that's going to be. So if you do half of 4 is going to be 2, so we have 2y. And then if we do half of 18, or half times 18, that's just going to be equal to 9. So notice how our variable terms match here, as well as our constant terms match as well. So this expression is equivalent. All right, finally for this last one, we have this -9 plus 2y. Notice this 9 here is technically a -9, right? If you were to rewrite this, this would be 2y plus a -9 if you add the opposite. So you got to really just see what's going on here. But we have a 2y, we have a positive 2 and a y, so looks like the variable terms match, the coefficients match. The constant here is -9. This constant's also -9. So remember, when you add, you can turn things around using the commutative property. So -9 plus 2y is the same thing as 2y plus -9. And if you add the opposite, or instead of writing add the opposite, you can subtract the opposite as well here. So you can go ahead and say this is going to be 2y minus 9, right? So this one technically is the same thing, just because we kind of turned around the addition problem here. So -9 plus 2y is the same thing as 2y plus -9. They're both the same thing. All right, let's try 11 and 12, last couple problems here. We're going to go ahead and apply our understanding of algebraic expressions and the distributive property and see how well we're understanding this concept here. All right, so the formula for the perimeter of a rectangle, that's all the way around the outside. If you're going to be adding this side plus this side plus this side plus this side, that's the perimeter, is going to be this formula 2L plus 2W. Hopefully that makes sense because we have a length on top. We also have a length on bottom. We have a width on the left side as well as the right side. So there's two L's and there's two W's. L is going to be the length, W is going to be the width. How can we use the distributive property to write an expression that's equivalent for this 2L plus 2W? Okay, so let's create a hypothetical value as well for the length and width to verify that it is the same. So it says, how can we use the distributive property? Well, to do that, I think what we're going to do here is we'll take the expression of 2L plus 2W. And let's see, do we have a common factor between the two? Well, they both have a 2 for a coefficient, right? There's a 2 here as well as a 2 here. So if we go ahead and take this 2 out in front, we could say this is going to be multiplied by one of these L's plus one of these W's. So this is kind of like that reverse distributive property, right? If you were to go ahead and distribute now, you would get 2L and you would get 2W. So this would be using the distributive property or reverse distributive property to rewrite the expression. So essentially we can use the distributive property to write the product of the GCF. So keep in mind that if you look at these two terms, they have a greatest common factor of 2 as one of their factors. So we have a product, so it's 2 multiplied by, that's a product here, right? Multiplication. The product of the GCF, again, which is 2, and the sum, it means we're adding of the terms here. So the L plus W, they're unlike terms. Next, we're told to create a hypothetical value for the length and the width to verify that these expressions are equivalent. So this is where you just kind of make up a different value of your choice. So for the length and width, just to make sure these expressions are the same. So I'm going to let L equal, I'm going to choose 5, and then I'm also going to let W equal 3. All right, so I'm going to let these be the values of L and W. So let's start with the original expression here. Let's start with this 2L plus 2W. So if we do that one, we have 2L plus 2W. This is just the original one, right? If we substitute in, it's going to be 2 multiplied by, I'm saying it's 5, plus 2 multiplied by, just say the width is 3. If we go ahead and multiply here, 2 times 5 is 10. 2 plus 3 would be 6. We would get a perimeter of 16 units, right? That's what the perimeter would be for this original expression. But what if we were to use this expression over here, which we're claiming is going to be the same, right? Let's see. If these are true, we should get the same answer. So we have 2 times the quantity of L plus W. And so we go ahead and substitute in here. It's going to be 2 times the quantity of 5 plus 3. Now using the order of operations, 5 plus 3 is going to be 8. So we have 2 times 8. And you can see here that we do end up with 16 units. So no matter which way we do this using the original expression or our factored or reverse distributive property expression here, we do get the same answer using our hypothetical values of this 5 and this 3. This should give us confidence that we did a good job with our distributive property understanding here, and we just verified using 2 hypothetical values. Again, you did not have to choose 5 and 3, you could choose any 2 numbers you'd like. Now for number 12, we're going to go ahead and explain why the expression we wrote in question 11 may be easier to use than this 2L plus 2W. So really we're being asked if we're going to compare the expression that we wrote, which is going to be 2 times the quantity of L plus W. They're saying why might this be easier than using the 2L plus 2W that people typically see. All right, so keep in mind that typically when you're given problems with rectangles, they really just tell you the length and the width. So a lot of times they'll just give you a rectangle. They'll say the length is, oh, I don't know, something like 6, and they'll say the width is something like 4, right? They don't typically go ahead and say what the lengths and widths are on all 4 sides. So if they just give you both of those numbers, I think the idea here is you can use either one of these expressions, but this one's kind of nice because if they give you the 2 numbers, some people may just find it easier. It's technically maybe less steps, right? If you were to go ahead and find the perimeter of this thing here, you would essentially just take the 2 and multiply. You just have to add the 2 numbers, the length and the width together, right? So it would just be 6 plus 4 is 10, so we have 2 times 10 here, and we're going to end up with 20. So the perimeter of this rectangle would be 20 units. So how many steps were there here? There's really just adding and then multiplying. So we have a total of 2 steps or 2 operations to complete. All right. Again, it's not that either one's wrong. It's kind of just understanding maybe the pros and cons of using each one of these. So it's like, why might this be easier than using the original expression that people typically use? Well, our typical expression is 2L plus 2W, right? So how many operations are in this expression? Well, it's 2 multiplied by L, that's one operation, and it's 2 multiplied by W, that's a second operation. But then you have to add those two products together afterwards. So that's 3 operations, right? So if we go ahead and use those hypothetical values that we just said for 6 and 4, it'd be 2 times 6 plus this 2 times 4. Right? And so if we go ahead and simplify this again, 2 times 6 would be 12, so that's one operation. 2 times 4 is going to be 8, that's a second operation. And if you go ahead and add these two together, we're going to get 20, that's a third operation. So we do get the correct perimeter in both situations of 20 units here. But notice in this particular case, using the original one, we have 3 operations that we completed instead of the 2 operations that we did earlier. So it's not that either one's wrong. One's one less step, one's one more step, but one you maybe are more used to seeing because maybe you didn't learn distributive property before. So if we go ahead and summarize this, the main advantage of using this 2 times the quantity of L plus W instead of the 2L plus 2W is that there's one less operation that you have to go ahead and evaluate or compute, but you're going to get the same answer. So why not do one less step if you understand how to use this method as well? So there you have a few different practice problems on the distributive property as well as the reverse distributive property, also known as factoring when you get into higher level math classes. And hopefully you found the video helpful in understanding these concepts better and understanding how to apply it maybe to just looking at rectangles and an expression that you've seen in the past as well. So if you found the video helpful, please consider giving it a thumbs up. And as always, keep up the great work that you're already doing.